I'm going to show you guys what I think today are really, really weird and amazing graphs. Okay, they are rational functions, so they have that strange asymptotic behavior. Some of them do, at least. But I'm going to show you some graphs today that just, I don't know, I think they're really amazing. Hopefully you do too. If not, then whatever. It's just another thing you got to learn. So I'm going to show you two functions today that are very similar to each other. And I'm going to use a thinner marker. There's f of x equals x squared minus 2x over 4 minus 2x. And a very, very similar function, g of x equals x squared plus 2x all over 4 minus 2x. Okay? They're pretty close to being the same thing. So you would think that they look kind of the same. You would possibly suspect that, right? They look very similar except for one difference.
Oh, one has the same thing in the denominator and the numerator.
What?
Anyways, it looks the same, yes.
It looks the same, but what's the difference?
Plus 2x and minus 2x.
Yeah, there's the minus sign and the plus sign. That's the difference. And even though that seems like a very insignificant difference, you're like, whatever, plus becomes a minus or minus becomes a plus. Who cares? It actually does something really crazy, really weird. I'm smiling because I think this is amazing. Watch it not be and be like, really, that's it? Okay? So, tell me, first of all, let's just analyze these graphs a little bit. What are the vertical asymptotes and x-intercepts of each of these functions? First of all, what are the vertical asymptotes?
Sorry, what's that?
Vertical asymptotes, what are they?
0.
No.
4.
Same thing as non-permissible values.
2.
Oh, it's 2.
2?
Positive 2.
Yeah, you take the denominator, right, and make it equal to 0. And then solve for x. So just really quick here. Divide both sides by negative 2 makes it positive. So there's our vertical asymptote. Okay, x-intercepts. This is for both f of x and g of x. X-intercepts, how do you find those?
You just put 0 in for y.
Put 0 in for y, right? So let's take f of x, make it equal to 0, and now we're going to solve for x. How do I do that?
Well, should have multiply.
Do some cross multiplication. So basically this entire bottom term disappears because it's 0 times all of that, right? So you have 0 equals x squared minus 2x, and then factor that, so you have x times x minus 2.
Oh, you can multiply 0 by the bottom term?
Yeah.
Oh,
Yeah.
I didn't think you could.
So x is 0 and 2 for the x-intercepts. Okay? And then g of x...
But with the x-intercept,
yeah,
the non-permissible value is 2.
How does that work?
So how?
Well, that's interesting. So that wouldn't be an x-intercept.
It's extraneous.
Yeah, it's extraneous. Huh. Interesting. Okay. And g of x. So x squared plus 2x. Got a plus in there, so that'll change things just a tiny bit. And put it over 1, cross multiply. This guy disappears again. So you have 0 equals x squared plus 2x.
Interesting.
So you have 0 and negative 2. Okay, so that's just some of the characteristics. Now, we're going to graph them, y1, y2, and you're going to see something really crazy. I think it's crazy. Okay, so let's graph these. Calculator's on. X squared minus 2x, this is f of x, over 4 minus 2x. And then the other guy was x squared plus 2x over 4 minus 2x. And make the second graph bold, just in case they're really, really similar. Okay, make the second graph bold. Oops. Okay. Follow me? Remember, the only difference is a plus and a minus. They have the same asymptotes. Their x-intercepts are a little bit different, but yeah, check this out. So, what do you guys notice? Right? They're so different. What the heck? Yeah, is it like, look at this. There's a line. No, I want it to be thick still.
I don't understand how one can just be a line.
So I'll turn that one off. Yeah, that's f of x. How is that? But that's a rational function. Where's the asymptote? Where was the asymptote supposed to be? 2, right? What if you trace 2? Trace 2. What's the y value?
It doesn't show up.
So there's nothing there at 2?
You want to see what's there?
There's a point of discontinuity.
Yes. Is it like really small or something? So you do the zoom.
So cool, huh? It's a hole right there. There's a hole in the graph. If you zoomed in, I did this. It took me 20 times. It took a long time. I kept zooming and zooming, zooming, zooming. And when I did it, when I was in grade 12, it was a hole. But maybe the technology has changed since then. So turn the page in your notes. This is what I saw when I zoomed in around 20 times. And in the bottom right there, those are the window settings that I used. So it's restricted tightly around 2 of x and -1 for y, because that point is 2, -1. At least it should be. But that's what 2, -1 looks like. In a really, 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 really zoom. Like, don't waste your time zooming in, because you'll.
I'm wasting my time.
Okay. Doing it for dumb. But that's what it looks like. Really, really close. Okay. I have another graphing program called GeoGebra, and here's what happened when I zoomed in. I labeled just an arbitrary point. This is 2, -1, and I just zoomed in there, really, really tiny, and it did some really strange things.
Why is it bigger?
Right? Yeah, I don't understand why. Like, because there should be no breaks. It should be a solid, thick line, right? It doesn't make sense that it's breaking up. But my suspicion is that this is just an error in technology, because really, what this should look like, it should just be line with a gap and line. That's what it should look like. There should just be a hole there. In fact, when you graph it, it's usually done like this. You put a circle where that point of discontinuity is. But for some reason, the graphing technology that you have in your hands and this software here just, I don't know, goes haywire when you zoom in really, 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 really tiny.
That's going to make life really difficult.
That's weird, right?